the functions.
A function is a relationship or expression involving one or more variables.
I'm Fisherman Billy.
And I'm Fisherman Bob, and we are the Hicks.
And we like to fish.
And we like to teach.
Yeti.
Hello, my name is Chuck. I am the nice cowboy around these parts, people call me. And I was raised in Odessa, Texas, and my mother and father, although they were farmers, on their side job, they were actually teachers as well. They taught me math, science, that's about it.
Oh, I'm Freddy the Werewolf! I'm Tom Bidley the Great, and I like to teach kids! My name is Helga. I'm a teacher. None of my kids listen. I like to teach. That's it. Get out of my face. Linear functions. Linear functions is a straight line. Straight line. Okay? It's the formula. Okay, listen up. Y equals mx plus b. Y equals mx plus b.
So this right here is a linear function example. So we have to graph 25 plus 3x. And since 25 is right there, it goes through 25 on the y-axis. And since it's plus 3x, which is mx, m is for the rise, and x is for the run. And rise is 3 and goes over 1 because 1x. And so, here's an example of how to solve it, because if it's not in y equals mx plus b, what are you going to do? So this is it. First off, we have to isolate y. So you do minus 4y. And just put it over there. So now you got 16x minus 38 equals negative 4y. Can't have this negative 4 over here, so now you get that to this side. So you divide by negative 4 to everything over here. And you get negative 4x plus 9.5 equals y. And that's how you solve a linear function equation.
We're here to discuss domain and range.
That there's the domain, that there's the range. Now let me tell you this. Domain and range, when you got two arrows extended both down and up, is going to be all real numbers. Because those domain arrows, they go to infinity, all real numbers across the board. Quadratic function. Okay? A quadratic function is a function that can be described as, ready for this, y equals ax squared plus bx plus c. You get it? Okay, now listen to this. This will blow your mind right here. A cannot be, no, this marker does not work. A cannot be equal to 0, and a quadratic function, quadratic, is always a parabola. Parabola.
So this is a quadratic function. Fun fact, you can actually FOIL a quadratic function. And I will show you how to FOIL right now. This is how you FOIL a quadratic function. You get two things in parentheses right here. You take this one, you bring it over here. Then you don't only multiply by the other 2x, but you also multiply it with the other number. So you get 2x times 2x and 2x times 2. So at the very end you get 4x plus 4x squared plus 4x. Then you do the same with the 2. So you bring that over, and bring it over again. So in the end you get 4x squared plus 4x plus 4x plus 4. And you get 4x squared plus 8x plus 4. Now what are we going to do with that answer? We're going to graph it right here. 4x squared plus 8x plus 4, and 4 is always the y-intercept. So right here is the xy graph. We're going to go 1, 2, 3, 4. Now we're at 4. And as you know from the previous thing that my friend showed a quadratic function is always a what? A parabola. So, we know the parabola is going to end at 4. So, draw a little line, boom, boom. And there's a little more to it on the calculator, but this is a very good showing of what it looks like in a graph.
Well, now we're here to learn about the domain and range of a quadratic function.
Domain. Again, you see the arrows, you know, we're getting all real numbers again because they're going for infinity. So, you go like a 2 like this, okay? Now the range is a tad different on a quadratic. The range, because we got y4 intercept, okay, y4 intercept, the range is going to be y is greater than or equal to 4, because we're going up. We ain't going down. This is nothing. We're going up. Exponential functions. Exponential. Okay? They involve exponents, and the variable is now the power. Feel the power of the variable rather than the base. Power rather than the base.
Our exponential function formula is y equals a, parenthesis, 1 plus or minus n, close the parenthesis, to the t to the power.
This is an example of an exponential function. My brother Lenny paid $28,000 for a new wagon. The value of the wagon decreases at a rate of 10% a year. How much will the wagon be worth after 5 years? So you're going to take how much the wagon was bought for, and you're going to put it into the function of 28,000, and then you're going to take the 10% minus, which was 0.1, and you're going to square it by 5. And you're going to plug that function into your calculator. This is going to give you $16,533.72. That's how much his wagon will be worth when he sells it in 5 years. Oh, the domain and range. Domain is from 0 to 5 years because of the years. And the range is y is less than or equal to 16,533.72. Oh! Rational functions. Rational, okay? A function that is the ratio rational, kind of the same, of two polynomials. Where there is x and y intercepts, asymptotes, and wholes. Rational.
This right here is the formula for a rational function. And the formula for a rational function is f of x, which is y, equals a parenthesis x minus h parenthesis to the power of negative n plus k. And in this formula, if you want to find the intercept for y, you plug in 0 for x. If you want to find the intercept for x, you plug in 0 for y, which is f of x, and then you solve through. And in this formula, h, which is located right here, is the horizontal shift. And k, located at the very end, is the vertical shift. And if you put h and k like this in an x and y form, this represents the new origin and the intercept of the asymptotes of the problem. And the domain, which is x, cannot equal h, horizontal shift. And the range, which is y, cannot equal k. And that is the function and the rules for a rational function. Right here we have an example of a rational function. And this function, which is f of x or y, equals 1 over x minus 3 plus 2. Or you can write it this way, which I explained earlier in the formula, which is f of x or y equals 1 times x minus 3 to the power of negative 1 plus 2. And after you find this, which is just the formula, the first step is to ID the problem, which is h and k, which h is the horizontal asymptote and k is the vertical asymptote. And the example is found is h equals 3. And this right here is negative 3, but it's not negative because it's a minus already. If it was a negative 3, it would be plus 3 in this problem. So right here the h is 3 and the k is plus 2 and the vertical asymptote is 3 and the horizontal asymptote is 2. And the domain cannot equal 3 and the range cannot equal 2. So now we're on the second step, which is to sketch the problem. And A, as we know, is 1 because it is right there and it is there in both the formula spots, it's A. And HK, it equals 3 and 2, which 3 being the horizontal and 2 being the vertical. So first you gotta sketch the point 3, 2, which we did. We went over 3, up 2, and then that's the mark at the intersection of the asymptotes. Then you have to draw the line with the asymptotes and where the formula puts it, and that's the second step. So this is the last step of a rational function. Third step. This one you're going to need a graphing calculator for, so reach in those book bags and get them out. It's coming. So first off, plug in the formula, and then you got to plug in 0 for x. So f of 0 equals 1 over 0 minus 3 plus 2. And this one, we're using the fraction one because it's easier than this one when plugging in to find zeros. So the next step, then you get negative 1 over 3 plus 2, and then you take the 2 and you add it to the fraction, and you get f of 0 equals 1, 2 over 3, which equals a, which is the first intercept, 0, and 1, 2 over 3. And then for the x-intercept, you find 0 by plugging in 0 for the y. And so 0 equals 1 over x minus 3 plus 2. Then you minus the 2 over to this side, flip-flop it, and you get negative 2 equals 1 over x minus 3. Then you have negative 2 over 1, and you cross-multiply with 1 and 1, and negative 2 and x minus 3. So then you get negative 2 times x minus 3 equals 1. And then you FOIL this negative 2 into the x and into the negative 3. So you get negative 2x plus 6 equals 1. Then you take the 6 and minus it over here into this part. So you get negative 2x equals negative 5, divide by negative 2, and you get x equals 2.5. And this is the horizontal asymptote for B, which is 2.5, 0. And that is how you find your intercepts for a rational function.